Okay, we're going to now find a solution to the integral of sine of the fourth multiple of x divided by cosine to the fourth power of x. Okay, initially you might recognize the reciprocal of cosine to the fourth power as secant to the fourth power. So you may be inclined to write the integral as the integral of sine of 4x by secant to the fourth power of x dx, and try and solve it through integration by parts. And I'll tell you right now, if you were to go down that road, I wish you luck, because this integral will turn into something quite nasty and unpleasant. So we need to be a bit smarter than just dive straight into techniques of integration. What I first need to do is to modify or transform this integrand so that the numerator and the denominator have the same form. And luckily, on a previous video, we found out how to use complex numbers and De Moivre's theorem to find multiple angles of trig functions. So let's get rid of that. Okay, so sine of 4x can be expressed as 4 by cosine cubed of x by sine of x minus 4 by cosine of x by the sine cubed of x. And if you're wondering how this came about, I will leave you a link in the description below, or you can click up here in the top right hand corner and you'll see how to derive this result for yourself. Okay, so now the expression sine of 4x over cosine to the fourth power of x is equal to 4 by cosine cubed of x by sine of x minus 4 by cosine of x by sine cubed of x all over cosine to the fourth power of x. So what I'm going to do now is to factor out a 4, factor out a cosine to the front. So I'm left with, inside brackets, cosine squared of x by the sine of x minus sine cubed of x over cosine to the fourth power of x. What I can also do is to factor out a sine of x, and I'm going to factor it out to the back of the expression. So now the term in brackets is simply cosine squared of x by sine squared of x, and I'm multiplying by 4 cosine of x at the front and sine of x at the back. Okay, so I should be consistent with my notation because I don't use a parentheses here, so I should get rid of these parentheses. It's not wrong to have them, but it's good to be consistent as well. Okay, this cosine of x can cancel with a power to reduce the power on the denominator by 1, so we have cos cubed of x on the bottom. So now the integral of sine of 4x divided by cosine to the fourth power of x dx is equal to the integral of 4 by cosine squared of x minus sine squared of x all over cosine cubed of x by the sine of x dx. We can simplify the integrand further. So the 4 can come out the front, so it's 4 by the integral of cosine squared of x minus, now by the Pythagorean identity, sine squared of x can be expressed as 1 minus cosine squared of x. And again, force of habit, let's delete these parentheses here. And now if I expand this negative into the parentheses, I'll have minus 1 plus cos squared of x. Cos squared of x plus cos squared of x is equal to 2 cos squared of x. And that is over cos cubed of x. So I have my fraction all in terms of cos of x. It just consists of numbers and powers of cosine, and I'm going to group the sine x and dx together. So I have sine x dx at the back. So now I'm going to let u equal cosine of x. Then the differential du is equal to negative sine of x dx. And that implies the term sine of x dx is equal to negative du. So substituting u into our integral, we get the integral is equal to 4 by the integral of 2 times u squared minus 1 on u cubed by negative du. So this fraction can be split into two fractions. So I have 2 by u squared on u cubed in the front, and I have minus 1 on u cubed at the back, and the square brackets indicates I have a negative that I need to multiply into here. So if I multiply the negative in, I simply switch the terms and the integral becomes 4 by the integral of 1 on u cubed minus 2. Now the u squared on top cancels with the power of 3 on the bottom to leave me just with u on the bottom. And we're integrating with respect to u. So we can write this all out now. So we've got the integral of sine of 4x over cosine to the 4th power of x dx is equal to 4. The first term integrates to u to the power of negative 2 on negative 2. Increase the power by 1, divide by the new power. Minus 2. Now the integral of 1 on u, of course, is equal to the log of the absolute value of u. And we add the constant of integration plus c at the end. Now u was equal to cosine of x. So we have cosine of x to the negative 2 on negative 2 minus 2 by the natural log of cosine of x. So simplifying further, if we multiply the 4 in, we get negative 2. Cosine to the negative 2 is equal to secant squared of x. And of course 4 needs to be multiplied by the 2 here, so that becomes negative 8 by the log of cosine of x. And we don't need this bracket here anymore. Okay, so finally the integral of sine of 4x on cosine to the 4th power of x dx is equal to negative 2 by the secant squared of x minus 8 by the log of the cosine of x plus an integration constant c. Let's box this answer. Okay, so the strategy here has been to change the numerator to the same form as the denominator using a multiple angle formula, and that allowed us to simplify the integrand to be able to use a u substitution. So I hope this has helped you. If you have any questions or comments, please feel free to leave them in the section below this video. Check out my hundreds of other tutorials and playlists to help you with your studies. Till next time, best of luck. I'll catch you on the next video.